Hello and welcome to another episode of the WEM Video Academy. Today we are going to have a look at building multi-factor authentication in a WEM application using basic authentication. Multi-factor authentication requires the user to authenticate in 2 or more steps after submitting the initial user credentials. Let's have a look at the basic authentication starter application available in the App Store of the MyWEM portal. The Basic Authentication Starter application features ready-to-use flows on user management, basic user authentication, password resets, and account activation for new users. In order to provide enhanced security, we will extend these flows with a process for multi-factor authentication using a mobile phone authenticator app. This will secure the authentication process even in case of compromised user credentials. We will refer to multi-factor authentication as MFA in this video. The multi-factor authentication setup will be done in 3 steps. In step 1, we will build a flow for creating a unique secret key for each application user. This secret key will be generated at first login. In step 2, we will generate a QR code to be scanned by a mobile authenticator app of choice. This will allow to register the login account in the app at first login. In step 3, we will present a dialog to the user requesting a multi-factor authentication code directly after submitting the user credentials. Let's start with step 1. We will use a combination of a calculated text field containing the allowed characters and the random function available in the math folder of the WEM expressions function library. We will create a circular flow building a text string of 32 characters from a random selection of the allowed characters field. This will be the secret code for the new user. Every iteration will add a character from a random position in the allowed characters field to our secret code string. Once the full length has been reached, the secret code is completed and the flow will end. In the second step, we will build an expression for generating the QR code and then submit this expression to the QR code creator widget. First, the expression itself. Let's break down the various sections. The first section starts the expression with the OTP auth prefix and the name of the account as it will show up in the Authenticator app. We will use the isPreview and isStaging functions to create separate accounts for the various runtimes of our application for enhanced security. The second section contains the user ID of the user requesting access to our application. This should be the value of the email field in the user list. The third section contains a query parameter secret and the value of the secret key of the user. Here we will use the value of the secret key session field we created in the previous step. The fourth section is also a query parameter and contains the issuer. This should be the same expression as the first section. The fifth and last section contains a couple of additional query parameters related to the encryption protocol, the length of the required MFA code, and the period of validity of the code in seconds. A sample of this expression is provided in the description below this video. Now let's get the QR code creator widget. You can find this widget in the Global Widget Library on the yellow tab. If you do not have this library in your project yet, you can add the library using the context menu. We will drag the widget into an overlay node. Then we will submit our QR code expression into the input text property. We will create a session file field for the QR code image and link it to the output data field image property. We can also set the QR code image size if we want it to be different from the standard size of 160 pixels. We will give the user the option to continue after a successful QR code scan or abort the process in case of any problems. If the scan was successful, the account was registered in the user's Authenticator app. That means we can now store the session code in a new field secret code in the user database list for future use. This field value will also be our check whether the user registered for multi-factor authentication before in case of a next login attempt. Now for the third step, the MFA code validation dialog. This is the only part of the flow that both new and returning users will pass through every time they log into the application. The MFA code can be captured in a numeric session field inside a simple form dialog. We will provide a short explanation to the user on what to submit here. However, do not make these messages too explicit. They are only meant for users familiar with the process, and you do not want to give too much information to unknown visitors. The submitted MFA code will be checked using the time-based one-time password or TOTP function. This function can be found in the security folder of the WEM expressions function library. The basic expression looks like this. We check a string version of the submitted MFA code against a time-based one-time password generated from the user's secret code and the current UTC date and time. To allow the user more time, we will display the previous and next code in the Authenticator app by checking the code provided 30 seconds ago and the code covering the next 30 seconds. The outcome of this check will be two different end nodes, one for TOTP check successful and one for TOTP check failed. A sample of this expression is provided in the description below this video. Now that we have built the three subflows, it is time to stitch all of them together in an overall multi-factor authentication process. Let's create a separate flowchart here, combining the three steps. This can be easily inserted in the basic authentication flow later on. The first thing we need to do is to check if the secret code field in the current user row has a value. This means the user registered his MFA account before and is a returning user. If yes, we will take the flow to the MFA code validation dialog directly. If no value is present, we need to execute the first two steps, generating a secret code and storing that in the current user secret code field after app registration, followed by the QR code display for the user to register the account in the Authenticator app. In case the user cancels the registration step of the process, the flow will exit into the new MFA failed end node. In case the registration is successful, the new user will also be taken to the MFA code validation dialog. The MFA code check may result in two outcomes. If the MFA code check fails, the user should receive a warning and be allowed a retry. You could build an extra node in here, limiting the retries to, for example, 3 times. Should the user cancel or fail any of the retries within the allowed number of attempts, the flow will exit into the MFA failed end node. In case the MFA code is accepted successfully, the flow will exit into the MFA successful end node. This will allow us to resume and finish the basic authentication process. The last step in the process is inserting the MFA flow in the basic authentication process. We will modify the navlogin process for this purpose. Looking at the bottom right of this process, we see the node setting the current user in case of acceptance of the user ID and password. We will insert our new MFA flowchart here. The basic authentication dialog success exit will be rerouted to the MFA process. You may choose to do this only for staging or live, since it is less relevant for preview and can be annoying during the application development phase. We will reroute the MFA success exit to the current user assignment and the MFA failed exit to the authentication error flow. This means the user will not be granted access to the application, even after providing a valid user ID and password. Let's test the process. In this example, we created a new user in our application without any previous login history. We will visit the login dialog and submit the new user ID plus the password set during account activation. As a next step, we see the QR code dialog appearing, explaining that the user needs to register for MFA in an Authenticator app of choice. We scan the QR code using the mobile phone Authenticator app and press continue once we see the account appearing in our app. The app will return a code which we will submit, and we will get access to the application. Now let's repeat this process as a returning user. After the login screen, we see that we are taken to the MFA code dialog immediately. Let's test the process with a random code and verify that we will not get access to the application. Try again with the correct code. And we are back in the application. We have now successfully implemented multi-factor authentication in our basic authentication application. May we suggest a security improvement? The current MFA code validation flow does not keep track of the used codes, meaning after successful submission of correct codes, they may be reused in the same or other sessions within the 30 or 60-second time frame, since we allow both the current code and the one of 30 seconds ago. This would allow for so-called replay attacks. There is a simple solution for this. We will log the last successful code validation timestamp and the code itself in the user record. For this purpose, we add a numeric field last MFA code and a date field last MFA validation in the user list. The MFA validation flowchart can now be improved as follows. First, we will check the code and the UTC date and time of a new validation against these fields. The validation will be performed only if the new code has not been used successfully before, or the time difference exceeds 60 seconds. We also check that these fields are filled in case there was no previous validation. In an unrelated change, we also replace the toString function by the PADL function for processing codes with leading zeros. If this retry condition returns false, we will refuse the validation attempt and report a required 60 seconds waiting time to the user. We will also clear the session MFA code input field. If the retry condition returns true, we will perform the actual validation. Should the validation fail, we will report that to the user and also clear the session MFA code input field. Also here, we replace the toString function by the PADL function for processing codes with leading zeros. Should the validation be successful, we will first log the current UTC date and time and the used code in the user record before we report the MFA code validation successful. Let's preview this security improvement. We will log in with a correct MFA code, and we will log out immediately afterwards. Now we log in again with a different code, and we can access the application again. There is no lockout period for new codes. Again, we log out and log in, but now we will try and submit the code used for the last successful login. This code is not accepted as reported by this dialog. We are faced with a 60-second lockout. Let's repeat this process with the same code over and over again until we reach the 60 seconds mark. No matter how many times we try, the same code is not accepted a second time. Since the validity of a code in our application is 2 times 30 seconds, the same code will no longer be accepted anyway after the 60-second period, even if the lockout is lifted. After completion of the 60-second lockout period, we will see that the same code is now reported invalid. You could, of course, choose different validity and lockout times yourself. We can still submit a new code and we will gain access to the application again. And that concludes our video. We hope you enjoyed it. Please leave your feedback in the comments below and share the video with your colleagues and friends. We hope to see you soon again in the WEM Video Academy.